like the video and subscribe it. Really helps the channel to grow. Today I will discuss 9701 paper 3 May June 15. So you know that the first question mostly in the paper 3 is titration. So this is question 1. HA is an organic acid. Solution Fa1 was prepared by dissolving 13 point. These are the information which you must read very carefully. Dissolving 13.1 gram and underline the key points while reading the question of solid HA in each decimeter cube of the solution. You are to determine the relative molecular mass MR of HA by titration with aqueous sodium hydroxide. The equation for the reaction between HA and sodium hydroxide is given. This is also very important and it is used in calculation. Fa1 is a solution containing 13.1 gram per dm cube of organic acid HA. Fa2 is 0.100 mole per dm cube sodium hydroxide. Bromothiamine blue indicator is used in this titration, and method is before filling the burette you must clean the burette with distilled water and as well as with Fa1 solution. Fill the burette with Fa1. Use the pipette. Pipette should be cleaned before performing or before taking the liquid from or transferring the liquid from beaker to the conical flask. So use the pipette to transfer 25 centimeter cube of Fa2 into a conical flask. Add a few drops of bromothiamine blue indicator, whose end point is given because this indicator is blue in alkali and yellow in acid solution. And you know that your solution in burette is Fa1 and Fa1 is organic acid. So your end point should be yellow. Okay, perform rough titration and record your burette reading in the space. So perform a rough titration and record your burette reading in the space below. So in the space below you must draw a table, which I have drawn in my first video like this. Use scale for this purpose. So make 3 columns and 2 rows. Final burette reading, and always mention the unit centimeter cube, and initial second row is for initial burette reading, and final is the volume of HA used. Fa1 is used 1 centimeter cube. Please don't forget to write down the unit of the volume. So the first titration final burette reading for, let's say the final burette reading is 25.60 and initial reading is 0.10, and by subtracting initial reading from the final reading we get the volume of Fa used, that is 25.50, and the rough titration is 25.50. Now follow the instruction written in your paper. Carry out as many accurate titration as you think necessary to obtain consistent results. Consistent results are, you can say, concordant results mean the difference between two readings should be 0.10, not more than 0.10. Record in a suitable form below all your burette readings and the volume of Fa1 added in each accurate titration. So we have drawn the similar table as we have drawn above, like and carrying out as many titration as we need until we get consistent results. So draw very neat. Table should be very neat. 1 reading, 2 reading and 3 reading. This is final volume, final burette volume, centimeter cube. Next, initial burette volume, centimeter cube. Volume of Fa1 used. And the last row for best titration or best result. Best titration result. So you are going to do as many titration as it is going to take to get our accurate values. Like if we have 25.30 is the final and initial reading is 0.10, the volume used is 25.10. Similarly, second reading is initial reading is 10.00 centimeter cube and final reading is 35.40 and the volume used is 25.40. Similarly, the third reading we have 6.10 and 31.20 and the subtracted reading is 25.10. So this is 25.20. So now we have two best titration, that is 25.20 and 25.10. So these are the best titration result. Now from show accurate titration results obtained to suitable value to be used in your calculations, show clearly how you obtain this result value. So we have two best titerations are 25.20 and 25.10. So there must always be at least two, so we can say accurate one, accurate two, and if we need to if we need to, we could have accurate 3 OK. That just depends on if you can get them the same the first time around for those first two. If not, you can do a third OK to try and get it the same. But the initial volume we always start and we refill our burette back up to 0, just because it always make it easier to be more accurate. So you start at 0, you can reach your final volume. Okay, let's say that it was 25.10 and 25.20. So for the 2 decimal places you get to your final volume and you get your volume 2. So now if these were totally different, I would do a third one, and then if I got something that's the same, I would use these values, so as long as they are the same. Or 0.10, so we have 0.10 difference between these two values, so we must use 25.20 plus 25.10 divided by 2 to get the average volume of the 25 centimeter cube of Fa2 required, that is 25.15 centimeter cube. So difference, if we are going to use our different accurates, so now once I have get these, then these are always going to be the question where they ask you to find the suitable values for your volume that is used in your titration. So you just show the calculation that how you obtain this value. So you must show the calculation how to get the average titration volume of Fa1 in the burette. So so this is the final volume. You must put 2 decimal places, and it does not matter that they are exactly the same or difference of 0.1. so if you won't get these marks, so now that we have got values, then you are going to get asked to do your calculation questions which show you're working in appropriate significant figures. Significant figures are very important in chemistry practice, always going to be 3 or 4. Okay, you can choose the 3 or 4 as long as these are your correct number of significant figures. And then the first question is usually always calculate the number of moles of sodium hydroxide present in the volume of Fa2 pipetted into the conical flask. So calculate the number of moles of sodium hydroxide present in the volume of Fa2 pipetted into the conical flask. So this is concentration, mole is equal to concentration into volume. We have concentration 0.100, so this is in the question, it is given sodium hydroxide is 0.100 and 25 centimeter cube of Fa2 is pipetted out, and volume is we have 0.025 decimeter cube. So the answer is n is equal to 0.100 into 0.0250 n of sodium hydroxide. So always mention that moles of which quantity you are calculating. So the answer is 2.50 into 10 raised power to -3. Next question is, use your answer to C1. and the equation on page 2 to determine the number of moles of organic acid used to neutralize 25 centimeter cube of Fa2. So by using mole ratio, so we have equation HAHA plus sodium hydroxide, there is 1:1 ratio. Ha sodium hydroxide 1:1. The moles of sodium hydroxide is 2.5 into 10 raised power to minus 3 and ratio x. So we have 2.5 into 10 raised power to minus 3 moles of acid. Use your answer to B and C. To calculate the number of moles of HA in 1 dm cube of Fa1. So we know that C2, this is C2, this is C2, and B is the volume of Fa1. This is the volume of Fa1. By using these two values, we can calculate the number of moles of HA in 1 dm cube of the Fa1 solution. We know that 25 centimeter cube contains 2.5 into 10 raised power to minus 3 moles. So what would be the moles in 1000 centimeter cube? So ratio x, the moles are 0.100 moles. Now calculate the relative molecular mass MR of the organic acid HA. So we know that number moles is equal to mass over MR. So mole dm inverse cube is equal to gram dm divided by mr. So we have concentration of acid in gram per dm cube. So mr is equal to 13.1. so this is given in the first page of the question, 13.1 gram per dm cube. So this is 13.1 divided by moles are 0.100, so the answer is 131. So mr of acid is 131. A student carrying out this method correctly with same concentration of reactant obtained a titer of 28.30 centimeter cube. Would this give a larger or smaller value of mr than yours? Explain your answer. This would give the larger values. This would give the larger value because we know that mr we know that concentration is inversely proportional to volume and mr is also inversely proportional to concentration. So with the same concentration obtain a titer of 28.3, so this would give the larger value because increasing the volume, concentration is decreased, and if we increase the mr, concentration is decreased. So this would give, if 28.30 titer is used, then this would give the larger value because of this. We know that mole is equal to concentration. Mole is directly proportional to concentration and to volume, while mole is equal to ms over mr, or this is equal to concentration into volume. So concentration is inversely proportional to mole. If we increase concentration, mr is decreased. If we decrease concentration or volume, mr is increased. So that's why concentration and volume is inversely proportional to mr of the compound. So if we increase the volume, it means mr is larger, and if we decrease the volume, mr is lower. So this would give the larger value because of this. So this is all about this question. So hopefully you understand this. If you understand, please like the video and subscribe my channel.